Assalamu alaikum wa rahmatullah. Today we will start with chapter 16, Polynomials, part 1. Our objective is expand and reduce algebraic expressions. We need the following materials: textbook, draft papers, pen and calculator. Expanding an algebraic expression. Expanding is the process of writing the product of factors in the form of sum. This is the distributive property. K into A plus B equal Ka plus Kb. We multiply K by the first term and by the second term. K into A minus B equal Ka minus Kb. We multiply K by A and then by minus B. A plus B into C plus D. We multiply A by C and A by D, then B by C and B by D to get AC plus AD plus BC plus BD. Example: expand and reduce the following expressions. The first example is minus 2x into x minus 5 equal. We multiply minus 2x by x to get minus 2x squared, and then minus 2x by minus 5 to get plus 10x. Second example, we multiply minus 3x by 2x to get minus 6x squared, and then minus 3x by minus 7 to get plus 20x, plus 4 times 2x to get plus 8x, and then plus 4 times minus 7 to get minus 28. We reduce to have the following answer: minus 6x squared plus 29x minus 28. Third example, 4x times minus 3x equal minus 12x squared. 4x times minus 2 equal minus 8x. Minus 1 times minus 3x, we get plus 3x. Minus 1 times minus 2, we get plus 2. Here we pay attention because we have minus before the product, so we multiply them and then we multiply by minus to give the answer. X times 3, 3x times minus, minus 3x. X times minus x, minus x squared, multiplied by minus to get plus x squared. Plus 2 times 3 plus 6, and then multiply by minus to get minus 6. Plus 2 times minus x, minus 2x, and then we multiply by minus to get plus 2x. And then we reduce, we have the answer minus 11x squared minus 6x minus 4. Application: expand and reduce the following expressions. Please pause the video and try to solve it. Solution: Part 1. 3a times 2a, 6a squared. 3a times plus 5 plus 15a. Minus 2 times 2a minus 4a. Minus 2 times plus 5 minus 10. We reduce it to get 6a squared plus 11a minus 10. Part 2. Minus 3a x squared multiplied by 5ax, we get minus 15a squared x cubed. Minus 3a x squared multiplied by minus 4, we get plus 12ax squared. Then minus 2 times 5ax minus 10ax. Minus 2 times minus 4 equal plus 8. We cannot reduce it since we haven't like monomials. Part 3. 5x times 2x, 10x squared. 5x times plus 1 plus 5x. Minus 2 times 2x minus 4x. Minus 2 times 1 minus 2. Here we have minus 3x multiplied by minus 4x, we get plus 12x squared. Minus 3x times minus 7, we get plus 21x. We reduce it, since we have like monomials, to give the answer 22x squared plus 22x minus 2. Part 4. We multiply the first two factors. X times x, x squared. X times plus 2 plus 2x plus 1 times x plus x plus 1 times 2 plus 2. Don't forget to put them between parentheses to multiply them by x minus 3. And then we multiply x squared by x, x cubed, x squared by minus 3, minus 3x squared, plus 3x times x plus 3x squared, plus 3x times minus 3, minus 9x, plus 2 times x plus 2x, plus 2 times minus 3, minus 6. We reduce them to get x cubed minus 7x minus 6. Expanding using remarkable identities. These are the remarkable identities. A plus b perfect square gives us three terms, a square plus 2ab plus b square. A minus b perfect square gives us three terms, a square minus 2ab plus b square. A minus b into a plus b equal a square minus b square, difference between two squares. Example. Expand using remarkable identities. To x plus 7 perfect square, it is according to the first rule. Square of the first plus 2 times the first times the second plus square of the second, which gives 4x squared plus 28x plus 49. 5x minus 1 perfect square, it is according to the second rule. Equal square of the first minus 2 times the first times the second plus square of the second, which gives 25x squared minus 10x plus 1. For x minus 2 over 3 into 4x plus 2 over 3. It is according to the third rule. It gives square of the first minus square of the second equal 16x squared minus 4 over 9. X plus 1 over 5 perfect square minus x minus 1 over 5 perfect square. We expand the first according to the first rule, which gives x squared plus 2x times 1 over 5 plus 1 over 5 exponent 2 minus. Since we have minus, we open the bracket. To expand the second factor, x squared minus 2x times 1 over 5 plus 1 over 5 squared, we expand it according to the second rule. Equal x squared plus 2 over 5x plus 1 over 25x. We multiply here by minus to get minus x squared plus 2 over 5x minus 1 over 25. And then we reduce the like monomials to get 4 over 5x. Application 1. Expand and reduce the following expressions. Please pause the video and try to solve it. Solution 1. Part 1. To x minus 3 perfect square, it is of the form a minus b perfect square, which gives 2x squared minus 2 multiplied by 2x by 3 plus 3 squared. Here we have minus. We open the parentheses. And then we multiply 5x by x to gives 5x squared, 5x times plus 7 to gives plus 35x, and then minus 3 times x minus 3x, minus 3 times plus 7 gives minus 21. Equal. For x squared minus 12x plus 9, the answer of the first bracket, and then we multiply all inside the parentheses by minus, and then we reduce them to get minus x squared minus 44x plus 30. Part 2. 3 over 2x plus 1 perfect square, it is of the form a plus b perfect square, which gives 3 terms, 3 over 2x perfect square plus 2 multiplied by 3 over 2x times 1 plus 1 square. Since we have minus, we open the bracket. Here it is of the form a minus b into a plus b. So the answer is square of the first minus square of the second. And then we reduce it to get the answer 3x plus 2. Application 2, Part 1. Expand and reduce x plus 1 perfect square minus x minus 1 perfect square. Part 2. Deduce the value of 2001 square minus 1999 square. Please pause the video and try to solve it. Solution. Part 1. X plus 1 perfect square minus x minus 1 perfect square equal. X plus 1 perfect square, it is of the form a plus b perfect square. So it gives a square plus 2ab plus b square. Since we have minus, we open the bracket, and then we have x minus 1 perfect square. It is of the form a minus b perfect square, so it will give x squared minus 2x times 1 plus 1 square. According to the rule, a minus b perfect square equal a square minus 2ab plus b square equal x squared plus 2x plus 1, the answer of the first bracket, and then we multiply all inside the second bracket by minus to get minus x squared plus 2x minus 1. We reduce like monomials, and then the answer is 4x. Part 2. 2001 perfect square. We can write 2001 as 2000 plus 1 perfect square. So it like x plus 1 perfect square. And then 1999, we can write it as 2000 minus 1 perfect square. So 2000 plus 1 perfect square like x plus 1 perfect square, and then 2000 minus 1 perfect square like x minus 1 perfect square. So x here is 2000. The answer in the previous part is 4x. So the answer here is 4 times 2000 equal 8000. Application 3. In the adjacent figure, EFGH and AFKL are two squares, such that EH equal x and EA equal 2 where x greater than 2. Part 1. Among the following expressions, which one represents the area of the shaded part? Part 2. Verify that the area of the shaded part is equal to 4x minus 4. Please pause the video and try to solve it. Solution. Part 1. Area of shaded part equal area of EFGH minus area of AFKL, since the area of the shaded part equal area of the big figure minus area of the small figure. Since EFGH is a square, so its area is side square. Its side is x, so the area of EFGH is x square, minus the area of AFKL. AFKL is also a square, so its area is side exponent 2. What is the side of the square AFKL? Its side is AF. AF equal to EF minus EA, which is equal to x minus 2. So the area is x minus 2 square. Part 2. X square minus x minus 2 square, we want to expand it, equal x square minus x minus 2 perfect square. It is of the form a minus b perfect square. Pay attention. So it gives us three terms, a square minus 2ab plus b square. And then we multiply all inside the parentheses by minus, and we reduce them to get 4x minus 4. This is your homework. And this is a summary of our lesson. Thank you for watching. Wassalamu alaikum wa rahmatullahi wa barakatuh.